Welcome to The Explainer. I'm your host, and today, we are taking a seriously cool microscopic journey into the fascinating world of chemistry and mixtures. You know, when we look around our daily lives, pretty much everything we interact with is a mixture of some kind, but they absolutely aren't all created equal. Have you ever wondered what exactly is happening right under the surface of the liquids we drink, use, and see every single day? Well, grab your imaginary lab coats, because we're going all the way down to the molecular level to uncover the science behind the whole shebang.
Okay, let's dive into this. Here is our roadmap for today. First up, we'll cover the invisible true solution, then the in-between colloid, followed by the heavyweight suspension. We'll wrap it all up with the ultimate mixture showdown and an ultimate memory trick. Let's get started. So, I want to start by posing a really simple question to you guys. Have you ever wondered why, when you vigorously stir a spoonful of salt into a glass of water, it just completely vanishes from sight? But if you try the exact same thing with crushed chalk, it just turns the water into this incredibly cloudy, gritty mess? It's a super relatable everyday mystery, isn't it? Well, the answer to this little riddle comes down entirely to what's happening at a scale completely invisible to our human eyes. Let's investigate.
Part 1. The invisible true solution.
Let's start by grounding ourselves with the textbook definition. A true solution is a completely homogenized mixture where extremely small solute particles are uniformly distributed throughout a solvent. Okay, let's actually break that down with a classic lab example. Think of sodium chloride, just your everyday table salt, mixed into water. When that salt hits the water, boom, a massive chemical breakdown happens. The salt separates entirely into distinct sodium and chloride ions. Then, microscopic water molecules rapidly surround these dissolved ions, distributing them completely uniformly throughout the whole beaker. They are so thoroughly mixed, it's literally as if the solid and liquid have become one single, unified substance.
And because these dissolved ions are just incredibly tiny, the solute particles are entirely invisible to the naked eye. They actually kind of cheat our vision. As a result, the mixture appears perfectly uniform and perfectly transparent. Furthermore, because they are flawlessly dissolved into the solvent, these particles never accumulate or settle at the bottom. No matter how many hours or days you leave that beaker sitting there on the lab bench, they stay put. Another fantastic example from our sources is copper sulfate. When you dissolve copper sulfate, it turns the water this remarkably brilliant uniform blue, yet the liquid remains totally crystal clear and transparent. No cloudiness whatsoever.
Part 2. The in-between colloid. Alright, so a colloidal solution is defined as a mixture with intermediate-sized particles that are dispersed throughout a medium, and crucially here, they are stable enough that they do not readily settle out of the liquid. Let's think about a normal glass of milk. To your naked eye, milk looks just as uniform as our salt water solution did, right? It just looks like one consistent white liquid. But microscopically, totally different story. The particles in a colloid are significantly larger than those tiny ions in a true solution, yet they're still too small to be seen individually by us. They aren't completely molecularly dissolved in the same way salt is. Rather, these intermediate particles are just stubbornly dispersed and suspended throughout the liquid medium.
Now, what's really interesting about this settling behavior is what happens if we were to run a time-lapse camera on our colloidal solution. Watch this. At 0 minutes, the intermediate particles are suspended. Fast forward to 30 minutes, the mixture remains completely dispersed. Fast forward again to an hour, or literally even several hours later, still, no sediment layer has formed at the bottom of the beaker. It's wild. Despite being physically larger than the particles in a true solution, colloidal particles forcefully resist gravity and just flat out refuse to settle down on standing.
Moving on to Part 3. The heavyweight suspension.
Okay, a suspension is a heterogeneous mixture containing large, visible particles that absolutely do not dissolve in the solvent. Remember that gritty chalk water we mentioned at the very beginning of the explainer? Well, that right there is your textbook perfect example of a suspension. When you aggressively drop chalk dust into water, it immediately creates this cloudy, visibly heterogeneous mess. And for the record, yeah, I definitely do not recommend drinking it. The particles here are so incredibly large that for the first time in our journey today, they are actually visible to the naked human eye. They aren't hiding at all. You can literally see the specks floating right there in front of you. Initially, those large chalk particles are violently distributed by the mixing, which gives us that cloudy, chaotic mixture. But wait, over time, as we let the beaker sit completely undisturbed, gravity firmly takes over. The heavy chalk particles begin slowly moving downward through the water. Finally, after sufficient time has passed, a clearly visible, thick layer of solid chalk sediment forcefully forms right at the bottom of the beaker.
These particles simply cannot stay dispersed like the colloid could. Their sheer physical weight and size pull them straight down.
And this brilliantly illustrates how this difference in size also dictates how they behave during filtration. If you take a true solution and pour it through standard laboratory filter paper, those tiny dissolved particles pass perfectly through the microscopic pores right alongside the water. You get absolutely zero residue. The same goes for our trickster colloid, actually. It passes right through without leaving any obvious residue. But our heavyweight suspension? No way. When you pour that cloudy chalk water into a funnel, the clear water passes through as the filtrate, but those large, bulky chalk particles get completely trapped on top of the filter paper, leaving behind a thick, solid residue. They are just way too big to fit through the pores.
Part 4. The Ultimate Mixture Showdown.
So everything we've covered today really comes down to this. Particle size is the boss. It directly dictates every single behavior we've talked about. The true solution has the smallest, invisible particles that never settle and leave no residue during ordinary filtration. Then the colloidal solution sits right in the middle, with intermediate particles that are generally invisible, also don't readily settle on standing, and manage to pass right through ordinary filter paper. And finally, the suspension stands alone with its massive, visible particles that forcefully settle on standing and get trapped as a solid residue by standard filter paper.
To really cement this macro to micro storytelling connection in your mind, I want you to lock this visual scale into your memory. It's a very simple rule of 3. First, the true solution, possessing the absolute smallest, extremely tiny particles. Second, the colloidal solution, stepping up to intermediate-sized particles. And third, the suspension, featuring the largest, heavy particles. When you fundamentally understand the physical size of what's floating around in that beaker, I promise you every other chemical property makes complete logical sense.
Which brings us to part 5, the ultimate memory trick. So the crucial point is making sure this sticks with you for good.
Here is your foolproof, bulletproof memory aid. It is just 3 simple words. Dissolve, disperse, settle. Say it with me in your head. Dissolve, disperse, settle. The true solution totally dissolves. The colloid manages to perfectly disperse. And the suspension? Well, it's just too large and heavy, so it simply has to settle. Dissolve, disperse, settle. If you can remember those 3 words in that exact order, you've completely mastered the entire concept.
Remember the absolute golden rule of our lesson today. Particle size directly dictates both settling and filtration behavior. So the next time you pour a morning glass of milk, or aggressively stir a spoonful of sugar into your hot tea, or even wash heavy dirt off your hands in the sink, I want you to stop for a second and ask yourself, am I looking at a solution, a colloid, or a suspension? What other invisible mixtures are surrounding you right now in your everyday life? Keep questioning, keep exploring the incredible science all around you, and I will see you right back here in our next explainer.
Like, subscribe, and join us for more amazing videos!